everyone, welcome back. We are going to start again with lesson 93, and that's going to start on page 484. So make sure you have your books, pencil, and paper, and we're going to get started. I just wanted to show you around the Google Classroom just a little bit. So I'm sure you've seen this. Most of you have seen it or written questions. That's great. If you have questions on a specific lesson, so say you're doing lesson 91, view the assignment, you are able to ask questions within the lesson. So give me a second. Add class comment right here. So if you had a question about a particular problem or process, just ask it here. And once again, that's in the main page. So you have our main page, classwork, view assignment. Mine will look a little different than yours since I have the teacher version of it. And then under the lesson, you can add your own class comment here. Okay, so if you had any questions about that, that's where you can ask some questions. For right now, it looks like we might be doing this. We don't really know how long, so please let me know if you have questions that you'd like answered, or if you have suggestions to make the online learning easier, because we're all learning this together at this point. So one method that I thought would work was to have this sort of interactive whiteboard. So I write on this, you can see it just like we can in school, and then you'll just hear my voice. So we're going to get started on page 484. Ooh, there we go. Lots of little glitches, but it's okay. So I want you guys to take a moment, look at the mental math. I'll ask the questions, and I'm just going to say the answers right away. Pause the video if you need more time. So letter A, 40 times 60. 40 times 60 is 2,400. 2,400, some of you would say. Letter B is 234 minus 50. 234 minus 50. And the answer to that, 184. Letter C is a percent question. What is 25% of 24? 25% of 24. The answer to that is 6. So good job on those. Letter D, $5.99 plus $2.47. $5.99 plus $2.47. The answer, $8.46. Letter E, decimals. So we have 1 2/10 or 1.2 divided by 100. 1.2 divided by 100. The answer. So if you remember in class, the technical way we would read this one is 12 thousandths. We've also, since I've been dictating some of these answers, I would say 0.012. Just remember the technical way is you read the number and then say the name of the last place value. So the number is 12. The last place value is the thousandths place. So we would say 12 thousandths. Letter F, 30 times 25. 30 times 25 is 750. Letter G, if x equals 5, what does 5x equal? I'll write this out a little bit. So if x equals 5, what does 5x equal? All right, so think about that. Our answer is going to be 25. 25. And then our last question for mental math is letter H. And I will just read this. I won't add anything to the end, so just follow along. 8 times 9 plus 3 divided by 3, the square root of that, times 6 plus 3 divided by 3 minus 10. So hopefully you were able to follow along. The answer to that is going to be 1. Simply 1. All right, so good job on that. And as you can see, looking at this page and from the title of the lesson, today we're just talking about classifying triangles. So we should already be familiar with the fact that triangles are three-sided polygons, but they're not all the same, and you've known that just in life, looking at triangles, seeing them drawn. They don't always have the same appearance. And so we classify them in two different ways. One of the ways we classify them is by their sides, and the other way is by their angles. So what we're going to do is we're going to go through and make ourselves these charts explaining what the different types of triangles are, and then you'll have some practice questions with those. So follow along with your paper and in your book. We're still on page 484. So our first type of triangle is called an equilateral triangle. Equilateral triangle. And if you look at the name, you can sort of see what type of triangle this is going to be. If you see equa here and then lateral here, what it basically means is equal sides. So our description, I'm going to skip over to the description column, is all three sides are equal in length. All three sides, I'm going to abbreviate it, but make sure you look in your book if you wanted a full definition. All three sides are equal in length. And draw these just as best as you can. Try to make them seem like they're equal in length. So we would say, if this were a triangle we were looking at, if one side was, sorry about that, if one side was 3 centimeters, then the rest of the sides would be as well. All right, equilateral. Our next type is called isosceles. An isosceles triangle. And we would define that as at least 2 of the 3 sides are equal in length. So when I write it over here, I'm just going to say 2 sides equal length. Now, technically, an equilateral triangle is also isosceles because it does have 2 sides equal in length. But if it only has 2 sides equal in length, we would also call it an isosceles triangle. Okay, so we've got at least 2 sides equal in length, and that gives us an isosceles triangle. I'm just going to put these dash marks here to show that those are the same length. Isosceles triangle. And then our third type, classified by side, is called a scalene. Oops. Scalene triangle. And in this third type, maybe you could just guess it, all 3 sides are going to have different lengths. So none of our sides are equal. All 3 sides different lengths. Sorry about that. There was an ant crawling around. Thanks. And when you draw this, you don't have to be too crazy about it, but you just want to make sure that none of your sides could be equal. So these lines aren't the best, but you get the idea. And I have a picture in just a little bit so you can get a full idea of these 3 different things. So equilateral, all 3 are the same. Isosceles, at least 2 are the same. And then scalene, all 3 are different lengths. Okay, so if you are following along on page 484, you'll see at the bottom that it's telling us about the triangles we just learned and telling us a little bit more about the angles within. So it says an equilateral triangle also has 3 equal angles within. So I'm just going to put a little extra column here. 3 equal angles within. So if we had protractors and we could measure, we would find that all 3 of those interior angles are going to be the same. If we knew it was equilateral, we wouldn't really need a protractor, but I'll explain that later. For isosceles triangles, we are going to have at least, so it has at least 2 equal sides, which means at least 2 equal angles. Oh boy. 2 equal angles. If you guys are wondering why I always click out and click extra things, it's because the screen is touch screen, and so I'm always bumping into one of these buttons at the bottom. And finally, scalene triangle. All 3 angles are going to be different. Three unequal angles. So equilateral, all three sides are the same. All three angles are the same. Isosceles, two equal sides. It's also going to be two equal angles. And scalene, all three are going to be different. All three sides are different lengths. All three angles are different measures. Okay, so that's classifying by sides. Next, we're going to consider triangles classified by their angles. So like I said, if you need to stay there and fill out your columns, just pause the video there. But we have triangles classified by their angles. So we've already learned the terms acute, right, and obtuse. And we're going to use those three words to describe three different types of triangles. So the first one we're going to have is an acute triangle. So try to remember what acute means. What does acute mean? Okay, so that means the angle is going to be less than 90 degrees or less than right. So all three angles are acute. So although we don't know anything about the sides of these angles yet, the sides of this triangle, you can tell by looking, basically. You never really want to tell by looking, but you can sort of tell by looking that these angles are less than 90 degrees. Our next is a right triangle. So remember what right means. It means we have an angle of 90 degrees. We usually denote that with that little square in the corner to show that it's a right angle. So in a right triangle, it's going to have one right angle. And I'm going to carry on by denoting it with a square. And finally, we have obtuse. So remember what an obtuse angle is. An obtuse angle is larger than 90 degrees or larger than right. And so in this type of triangle, we will have one obtuse angle. So one good way to draw that is to just start off by drawing your obtuse angle. Draw one that's obviously larger than 90 and then just connect the endpoints of those line segments. A little shaky, but you get the idea. I'm going to draw it again. It's kind of better. It's okay. So these are three triangles classified by angle instead of by side. Acute, right, and obtuse. So on this next slide, I have an image of those different types, just so you can see. So if you look here, equilateral, isosceles, scalene, those are the first three we talked about. They're going to use this word congruent instead of equal. So that's more of a geometry term, but it's good for you to get familiar with it now. So congruent means same size, same shape. So to say that all these sides are congruent means that they're just exactly the same. So that's equilateral. All sides are congruent. Isosceles, two sides are congruent, and so you see that they have these line markings as well. These line markings, just because they each have one mark, means that they're the same length, and this second one just means it's of a different length. And then scalene, no sides are congruent. And then classifying triangles by their angles, acute, obtuse, and right, just like we talked about. So acute, all angles are acute, and if you can see here, maybe I can zoom in a little. I know I can somehow. There we go. A little blurry, but you can see that all of these angles are 60 degrees, so that is less than 90. In obtuse, we need one that's greater than 90, so 124 is greater than 90. In a right triangle, we need one right angle, and that's what we see here. Okay? So that's another image of triangles classified. So if you want to draw those and use those terms, if you'd rather use the term congruent, that's great. If not, you can just keep the charts that we drew together. And then I'm going to give you a moment to work on the practice set. So the practice set is mostly true and false questions. So you'll need to think about what these definitions really mean and how they apply to the different triangles. So that's on page 485. So pause the video for a minute and do all three of those really quickly. Okay. So letter A says one side of an equilateral triangle measures 15 centimeters. What is the perimeter? So we need to remember equilateral means all are the same length, and perimeter means the distance around. So what's the distance around an equilateral triangle with a length of 15 centimeters? The perimeter would be 45 centimeters. So the reason I'm breezing through these is because these are ones you're supposed to do on your own, but if you need help, I'm walking with you through them now. So 15 and 15 and 15 would be 45. Letter B says to verify. An equilateral triangle is also an acute triangle. True or false? True or false? Is an equilateral triangle an acute triangle? The answer is true. So let's think, why would an equilateral triangle be acute? It looks acute, but can we verify it? So what you need to know is that each angle in an equilateral triangle is going to measure 60 degrees. This doesn't matter what size the triangle is. If it's equilateral, the interior angles will always be 60 degrees. Because all of those angles are acute, it is an acute triangle. So an equilateral triangle is an acute triangle. Letter C, all acute triangles are equilateral. True or false? That's a good question. So we know all equilateral triangles are acute, but are all acute triangles equilateral? The answer to that one is actually going to be false. So we could have a triangle where maybe one measure was 60, like an equilateral, but this one instead is 50 degrees, and this one's going to be 70 degrees. So all of those measures are still acute, but it's no longer going to be an equilateral triangle. Letter D, two sides of a triangle measure 3 inches and 4 inches. If the perimeter is 10 inches, what type of triangle is it? That's a good question. So they're telling us the lengths, 3 inches and 4 inches. We have this missing side, but the perimeter is 10 inches. So you could add up the sides you know. And say, okay, what's this missing number? 7 plus what is going to equal 10? That missing number is going to be 3. So then it says, what type of triangle is it? How do we answer this one? We have a 3-inch side, a 3-inch side, and a 4-inch side. So hopefully you came up with the answer isosceles. And the reason we would call it isosceles is because it has 2 sides of equal length. And then finally, letter E. Every right triangle is a scalene triangle. True or false? Interesting. Every right triangle. So is it true that every triangle that has a right angle is going to have sides of equal length? Let's see. All right, hopefully you came up with the answer. False. Some of these are tricky. We could have a right triangle where these 2 sides are equal. That is perfectly normal. It's a special type of triangle that we'll learn about eventually, but it's definitely possible that a right triangle could have at least 2 equal sides. So a right triangle could also be isosceles. Okay, so your homework is on page 485. 485. Now I have assigned the whole lesson to you here, which hopefully isn't too overwhelming. It's what we used to do, so hopefully you have more time to do those things. So numbers 1 through 30, and like I said, if you have questions on these, please ask me in the comments of this lesson. So of lesson 93, please ask me in the comments there. And then one thing that might help you as well, since you can't just ask me directly, is if you look on these pages, like look at number 16. It says in parentheses under that number, it says a 42. That means that this question comes from lesson 42. So if you need a refresher, go back to that lesson to get some assistance.